The joule is the standard unit for energy in general. Other units for energy include the Newton meter and the kilogram meter squared over second squared. Kinetic energy is a scalar quality, which means it only has a magnitude and not a direction. It is not a vector. How is it different from potential energy? Kinetic energy is due to an object's motion, while potential energy is due to an object's position or state. So that might be important. When you calculate an object's kinetic energy, its velocity is an important factor. Velocity, however, has nothing to do with an object's potential. Example using a roller coaster. One way to think of the potential and kinetic energy is to picture a car on a roller coaster. As the car travels up the coaster, it is gaining potential energy. It has the most potential energy at the top of the coaster. Why is that? When you reach up to the top and you're sitting there, why is that? Mason, it's waiting to go down. It's waiting, right, it's waiting to go down. So up at the top, you kind of hesitate, right? And you're waiting and anticipating that drop. So it says, it has the most potential energy at the top of the coaster. As the car travels down the coaster, it gains speed and kinetic energy because it's moving, right? At the same time, it's gaining kinetic energy, it is losing potential energy. Why is it losing that potential energy when it's dropping?
It stops moving, so it continues moving and stops not moving.
Right, it's continuing to move, which means it's gaining that kinetic energy and losing that stored potential energy that it had at the top. It says at the bottom of the coaster, the car has the most speed and the most kinetic energy, but also the least potential kinetic energy. So we'll skip on down from the example problems, and it says interesting facts about kinetic energy. First one says if you double the mass of an object, you double the kinetic energy. So if you have a feather and you've also got a marble, and I drop both at the same time, which one's going to hit the floor first? The marble, because it has more mass, right?
Yeah.
So we know that that first fact is because of the mass. The second one says if you double the speed of an object, the kinetic energy increases by 4 times. This third one says the word kinetic comes from the Greek word kinesis, which means motion. Yeah, the next one says kinetic energy can be passed from one object to another in the form of a collision. So, if a car is parked on the side of the road and you're driving, you're not paying attention, you look down at your phone and you hit that parked car, is it just going to stay parked? No. No, what's going to happen to that car?
It's going to roll.
It's going to move too because you've given it that energy to make it move. So a collision can cause kinetic energy. The term kinetic energy was first coined by mathematician and physicist Lord Kelvin. Okay, so moving on, if you will get the potential energy article, and really quick, we'll do the same thing and important highlight that important information, the key details in the text. I think this one's a little bit smaller, so we'll just go through this one really fast. Okay, it says, physics for kids, potential energy. Potential energy is the stored energy an object has because of its position or state. A bicycle on top of a hill, a book over your head, or a stretch spring all have potential energy. The standard unit for measuring potential energy is the joule, which is abbreviated as J. How is it different from kinetic energy? Potential energy is stored energy, while kinetic energy is the energy of motion, which we just learned from the other article, right? When potential energy is used, it is converted into kinetic energy. You can think of potential energy as energy waiting to happen. A car on a hill. We can compare potential and kinetic energy by considering a car on a hill. When the car is at the top of the hill, it has the most potential energy. If it is sitting still, it has no kinetic energy. As that car begins to roll down the hill, it loses potential energy but gains is getting converted into kinetic energy. Gravitational potential energy. We talked about gravitational energy, correct? Yeah. One type of the potential energy comes from the Earth's gravity. This is called gravitational potential energy, GPE. Gravitational potential energy is the energy stored in an object based on its height and mass. To calculate the gravitational potential energy, we use the following equation. And again, that equation looks pretty scary, but we don't have to worry about it. Okay, potential energy and work. The potential energy is equal to the amount of work done to get an object into its position. For example, if you were to lift a book off the floor and place it on a table, the potential energy of the book on the table will equal the amount of work it took to move the book from the floor to the table. So, interesting facts about potential energy. Potential energy is the energy that an object stores. It is the energy that an object possesses when it is not in motion. And an object slows down. As an object slows down, the potential energy increases. And as an object speeds up, its potential energy decreases. Okay. So, will you hand these out for me? I have created a worksheet over potential and kinetic energy. And I know that it has a typo. I don't know why. But right here, this is supposed to be the word it. Right here. So if you want to cross that out when you get it and just type in it or write in it and fill this out, and when you're done, if you'll just place it on this table up here for me, because I have an activity for you all. Yeah, so each one of these you're going to have to decide whether or not to put potential or kinetic energy in the space. Yeah, absolutely. Thank you. And you can work with a partner beside you if you need help doing it. Remember, the important information that we've highlighted throughout our articles, you can use that to help you fill out this worksheet. Did you not get one? That's okay, I've got one. And in the bottom corner, the 1 and 2 on the bottom, you can come up with a word to stick in there.
Which one at the bottom?
These at the bottom, so you can just come up with a word, a verb, put in there instead of kids are doing.
Thank you.
Not yet. We'll go over it.